Hello, in this video I'm going to explain dividing fractions. Now the good news is that dividing fractions is pretty similar to multiplying fractions, but there is one step we have to do ahead of time to change division to multiplication, and I'll get to that in a moment. Now they're going to give us some problems here initially to talk about a concept called the reciprocal. The reciprocal is just a fancy name for flipping a fraction. So let's take this number here. Let's look at number 1. So 6/7. The reciprocal means switching out the numerator and denominator. In other words, just flipping it upside down, flipping it over. So the 7 becomes the numerator, and the 6 becomes the denominator. All right, so this is called the reciprocal. Find the reciprocal, it says. We just simply flip the fraction upside down. All right, so sometimes it's called the multiplicative inverse, but I won't get to into that right now. Right now, we just want to know how to find the reciprocal of a number. And for this problem, we're just going to flip the fraction upside down. So 7/6. All right, well, that one's done. Well, how about the reciprocal of 4? How do we do that? That's strange. There's no denominator. Well, there's no numerator. We just got a 4 here. Well, actually, going back to our previous video, if you watched that video beforehand, recall that any number could be written as over 1, and it will not change what that number was. See, this number originally was 4, right? Well, let's simplify this. Let's see what we get. What is 4 divided by 1? 4. 4. So these two are equivalent. So whenever they give you a whole number and they say find the reciprocal, simply put a 1 underneath it. That's the first step. Then you can go ahead and simply flip, right? Flip it up over. So the 1 goes on top, the 4 goes on bottom. So we're swapping out numerator and denominator values. So 4 became 4/1, which then became 1/4. All right, so this is the reciprocal. So let's type that in there and see if it works. 1/4. And there's a reason they're explaining this to you right now, and you'll see coming up when you actually have to divide fractions. All right, so now we got 6/5, and I think you're probably getting the hang of it, right? So we have to find the reciprocal, so we change positions of denominator and numerator, so the denominator becomes the numerator here, the numerator becomes the denominator here, and there it is. So 5/6. All right. Let's keep moving. So we have 1/3. Okay, find the reciprocal. So again, we're going to change the positions of denominator and numerator. So we have 3/1. All right, so this is the reciprocal, 3/1. So let's put that in there and see if it works, right? So it better work. Oh no, what happened? Oh, that's right. That's right. Always look at this blue wording down here. Always look at because this tells you what they want you to do. See, in actuality, we did take the reciprocal, but then it says to simplify. And 99% of the times when you have a 1 on the bottom, you want to get rid of it. So, and I knew this. I was just seeing if you caught it here, obviously. What is 3 divided by 1? It's 3. So sometimes you can start with a fraction and end up with a whole number. When that happens when you have a 1 on the bottom. Okay, so simply just put 3 down. All right, so here we go. Here we go. Now we're dividing fractions. We're dividing fractions. Now there's a technique for this, and before I get into the technique, I think it might help if I explain to you in a couple different ways how we come up with that technique. All right, so let me do a little sidetrack here, but bear with me because this is going to help you to realize why the technique works. It's really a shortcut more than a technique. But anyway, so let's go and do an example here. So let's say we have 6 over 5 divided by 2 over 3. Now, I know this doesn't quite look like this, and these are different numbers, of course, but actually they're both division, right? Look, we have a fraction on the left-hand side, which represents the numerator part, okay? We have the division symbol, which is a division bar, and we have a number on the right side, which represents the denominator. So this is being divided by this, just like this is being divided by this. All right, now, remember that what I just went over, right, about having a 1 on the bottom, right? And let's pick number 7. We can put a 1 on the bottom of 7, and the answer is just 7. What if we use that concept here? What if we made, now recall, this is odd looking. We have a fraction on top, a fraction on the bottom, and then another fraction bar. But remember, this is the numerator, this is the denominator, even though these are also fractions. Don't let that confuse you. Denominator, numerator. What if we can apply this concept here about having a 1 on the bottom? What if we could make the bottom, the denominator, become 1? What if we could do that? Actually, there is a way we can do that. And the way we can do that is to multiply by its reciprocal. Now, let me just pick a couple other numbers here. So let's say we have 2 over 5. If I multiply any number by its reciprocal, these are different numbers here. If I multiply any number by its reciprocal, you get 2 times 5 is 10. 5 times 2 is 10. 10 over 10 is 1. Whenever you multiply a number by its reciprocal, the result is 1. So this is how we're going to get the denominator to become 1. We're going to multiply by this reciprocal, all right? So here we go. So I'm going to multiply by the reciprocal here, which is 3 over 2. Now recall that we can't just do something to the bottom of a fraction, right? We don't want to mess up the ratio. Whatever we do to the bottom, we got to do to the top. We have to keep the same ratio. So if I'm multiplying the bottom, if this is the new thing I did, if I multiplied the bottom by 3 over 2, I got to do the same thing here. I got to do the same thing here. Now you're saying to yourself probably that, wait, you just totally messed up the fraction. No, I did not. Because look, this over this is 1. It's the same number. I don't care how crazy looking it is. This divided by this is 1. So this is really just a one big 1 here. It's 1. We're multiplying this fraction by 1. Crazy looking 1, but it's a strategic form of 1, so I can get the denominator to become a 1. All right? All right, so hang in there. Hang in there. Now, I'm just going to multiply across here. I know we can reduce and everything before we multiply. Just for the sake of showing you the work here, I'm going to multiply straight across. So here we have 6 times 3 is 18 over 10. And down here, we have 6 on top, 6 on the bottom. Okay. All right, so all I did was multiply across here, multiply across, and I multiplied across here like in the last video. When you multiply fractions, you multiply straight across. All right, well, let's keep going. Let's keep simplifying, reducing. Now, 2 divides into both here, correct? 2 divides into both. So 2 divides into 18 9 times. 2 divides into 10 5 times. Let's put the division bar here. 6 divided by 6 is 1. Oh, this is turning out to be nice. Because now we have 9/5 divided by 1. And what's any number divided by 1? That number, 9/5. See that? By multiplying by the reciprocal of this, we were able to get the denominator to become 1, and then we can just focus on the top. So really, let's look at the top real quick. So 6/5. Notice what happened here. Notice in essence what happened at see the numerator, the answer came from the numerator, correct? Yeah, look. We follow that trail. This became 1. It fizzled out. This answer was obtained from the numerator. So let's look at the numerator a little bit more closely. 6/5 was the original numerator. Then we were dividing this by 2/3. But what happened was eventually, after doing the reciprocal, we actually wound up multiplying by that reciprocal, correct? See, we multiply by the reciprocal of the division. So we multiplied by the reciprocal of the original denominator. And then we multiply straight across. We got 18 over 10, which became 9 over 5. And there it is. See that? So this is the numerator. So the takeaway here is that we multiplied by the reciprocal of the denominator here to help us find the answer. All right, so that's one way to explain to you why we're multiplying by the reciprocal, okay? By a reciprocal. Let me see if I can do another demonstration here of why that would work. So let's say we have 6 over 2. Now, we know the answer is 3 here, right? 6 divided by 2 is 3. What if we change this to multiplication? Now, dividing by a number is the same as multiplying by its inverse. So let me write this down here so you can see. Dividing the 6 by the 2 is the same as multiplying by the reciprocal of the 2. All right. So let me show you here. So we have 6 times. Now, what is the reciprocal of the 2? Now remember, you can put a 1 under any number, right? Doesn't change it. 2 over 1 is still 2. 2 over 1 is still 2. We didn't change anything. What is the reciprocal of 2 over 1? 1 over 2. Dividing by a number is the same as multiplying by that number's reciprocal. Let's put a 1 under the 6, as we did in multiplying fractions. Times 1 over 2. Multiply straight across, 6 over 2, which is 3. Well, we knew that way long ago. We knew that way back here at the answer is 3. But the point is, I just demonstrated to you that we changed division to multiplication by multiplying by the reciprocal of the denominator, okay, of the divisor, okay? Dividend, divisor. All right, so let's try something a little bit more odd looking. 6 2/3. Will this work? Well, let's try it out. Let's multiply by the reciprocal and see what happens. So I'm going to keep the 6, just like I did here, bring over the numerator, change division to multiplication, and I'm going to take the reciprocal of this. So 3 over 2. All right, okay, yep. So far, so good. I'm going to put a 1 under the 6, and then multiply this out. We get 18 over 2, which is 9. Which is 9. Yeah. So now here what we had, odd looking, we had a whole number on top of the fraction, and we had a fraction on the bottom. Still, it was the same process, okay? We kept the numerator. We kept it the way it was. We kept the dividend. We changed the operation from division to multiplication. And we took the reciprocal, or we flipped the denominator or the divisor. See that? It became from 2 over 3, 3 over 2. And then we just pretend it was multiplication after that. Things we're already comfortable with. All right, one last example of this side track that I'm doing here, and then we're going to blast through you'll see how helpful this was, this side track. So we have 6 over 5 divided by 2 over 3. All right, so instead of doing this, wherever it is, I lost it, down here, instead of trying to get a 1 on the bottom, like we did in the first case, no, it's too much work. I'm just simply going to multiply by the reciprocal, right? Because that seems to be quicker. This here seems longer. Let me go back to here. Now I'm just going to simply multiply by the reciprocal, like the rule says. So I'm going to keep the numerator, the dividend, the way it is, 6 over 5. I'm going to change the division to multiplication, and I'm going to take the reciprocal, I'm going to flip the denominator, the divisor. So this becomes 3 over 2. Now, we could reduce here, but just for the sake of showing you the steps, I'm just going to multiply it out. So we got 18 over 10, and this becomes 9 over 5. Oh, not bad, right? Not too bad. All right, very good. So guess what? You now know how to perform division by fractions. So by doing this side track with extra examples, I basically paved the way for you to work on these. You could probably do these yourself, but let's do these anyhow. Let's erase that and start. Question number 5. 2/7 divided by 3 over 2. So we'll keep these in the same horizontal direction, right? Because division could be written this way or the way I was showing you before, up and down. Don't switch it to up and down. Just leave it the way it is. Just leave it like that. Just remember, the left-hand part is the same as the numerator or the dividend, and the right-hand fraction is the denominator or the divisor. All right, just remember that. Now, one thing I do want to mention before I forget here, even though we could reduce before we multiply, when we're doing multiplication, we cannot reduce while in division mode. Do not make that mistake. Do not reduce when you're in division mode. Make sure you fully have knowledge of that, okay? Make sure you remember that. You first have to change division to multiplication, and then you can reduce before you multiply. Don't try to slash the 2's out here. No, can't do that in division mode. All right, so forget about doing that in division mode. All right. So here we go. We're going to keep the left-hand fraction the way it is. This represents the numerator in my previous examples. So I'm going to keep this. I'm going to keep this. So I'm going to keep the left-hand fraction the way it is. I'm going to change. I'm going to change division to multiplication. And I'm going to take the reciprocal of, or flip the right-hand fraction. So this becomes 2/3. See, now if we could reduce here, we would be able to, we could do it if we could, but we can't. And remember, we cannot reduce side to side. So nothing reduces here, 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 here. So we're confident that if we just multiply across and get our answer, it will be indeed the final answer. So our final answer is 4 over 21. So you want to keep this verbiage in mind. Keep, change, flip. You're going to hear me, and other instructors talk about keep, change, flip. This is what we're talking about. This is the process. So if it helps you, think of K, C, F. KCF. Not KFC, by the way. I'm not talking about chicken. Okay, so here we're talking about dividing fractions. KCF, keep, change, flip. So once you do this, you've converted a division problem into a multiplication problem. And we know how to do those, right? Because we did those in the last video. And here's our answer. 1/6 divided by 3/10. Keep, change, flip. Let's reduce before we multiply. That cannot reduce, that cannot reduce, that cannot reduce, that can reduce. I'm going a little quick here because you already mastered this, right? From last video, you've already mastered it. 2 divides into both, you said, correct. 2 goes into 10 5 times. 2 goes into 6 3 times. Can we now reduce these? No, you said, because they're side to side. Correct. So let's multiply across. 1 times 5 is 5. 3 times 3 is 9. So 5/9 seems to be our answer. All right. So once you get the concept down of keep, change, flip, and as long as you're good with multiplying fractions, it's just one more step. It's just one simple little step in addition to multiplying fractions. And that step is the KCF, not KFC, George, KCF step. All right. I'm thinking of chicken here. All right, so we have 35/3, keep, change, flip. Are we going to multiply across? No, absolutely not. We're going to reduce first. This begs for reduction. Oh, yeah. That does not reduce. That does not reduce. That reduces very nicely. The number that divides into both is 7. 7 goes into this 7 once. 7 goes into 35 5 times. Nice. The number that divides into both is 3. 3 divides into 3 once. 3 divides into 12 4 times. 5 times 4 is 20. 1 times 1 is 1. We do not need the 1 on the bottom because 20 divided by 1 is 20. Done. All right. So now we have this strange looking number. Are we going to let that stop us? No, we're not going to let that stop us. This is a whole number. And remember, a lot of times it helps to write a whole number when you're dealing with fractions. A lot of times it helps to write that whole number into a fraction. So how can we write this number as a fraction without changing its value? Well, let's move it up a little bit so we can put a 1 underneath it. That's how. So we got, let's change the 35 into 35/1. Let's change that. All right. So now we're going to do the keep, change, flip. Keep, 35/1. Change, division to multiplication. Flip, 13/7. Let's reduce before we multiply. So, does not reduce, does not reduce. No, yes. 7 goes into both. 7 divides into 35 5 times. 7 divides into 7 1 time. It's time to multiply across. 5 times 13 is 65, you said, correct? And you know that because 5 times 12 is 60. 1 more 5 gives us 65. 1 times 1 is 1, but we don't need the 1 on the bottom. We are done. $65. Now, let me just do something real quick here. Um, Let me do another example here, a side example, which I don't believe is in MyLabs Plus here. Let me just see real quick. Uh, mm, I don't quite see it. So let me do a quick side example of what I'm trying to say here. So let's say we have 5/7 divided by 20. So what happens when the whole number is on this side? See, the last example, we had a whole number, and it was over here. We just put a 1 underneath, right? The one we just finished. So what do we do for this situation? The same thing. The same thing. Put a 1 underneath it, okay? Keep, change, flip. So you still keep this. You still change division, multiplication. Now you take the reciprocal of the 20, which is 1/20. And now you can just cancel before you multiply. Don't really need to finish this off here because my point was to show you how to handle that situation. But since we're here, let's finish it off. 1 times 1 is 1. 7 times 4 is 28. And there it is. So that's how you would handle this. When you have a whole number here as the divisor, put a 1 underneath it. That way when you flip, it becomes 1 over that number. All right, so let's keep rolling. Trying to cover situations you're going to run into in Math 50. I'm covering it here, even though it's not in this course, but the purpose of this course is to get you ready for Math 50 anyhow, right? All right, so we have 2/5 divided by 14/9. Keep, change, flip. Nothing has changed. Keep, change, flip. That reduces. Let's go for it. Let's go for it. 2, you said, goes into both. 2 goes into 2 once. 2 goes into 14 7 times. Nothing else seems to reduce. Let's multiply across. 1 times 9 is 9. 5 times 7 is 35. Done. Okay, just more of the same. More of the same. Keep, change, flip. Keep, change, flip. Now the temptation here, right? The temptation is to get rid of the 1, but keep the 1. We know 6 divided by 1 is 6. But this 1 underneath here helps us to realize that, yeah, we're going to multiply straight across or reduce up and down or diagonally. It helps us to stabilize this fraction. Okay, so keep the 1 here. So here's a good example of where it helps to keep the 1. But now is your final answer. All right, so that does not reduce. That does not reduce. No, yes. What number? What's the biggest number that divides into 6 and 6? You did not say 2 because 2 is too small. You did not say 3 because 3 is too small. Instead, you said 6. Correct. 6 divides into 6 once. 6 divides into 6 once. Multiply across. 7 times 1 is 7. 1 times 1 is 1. We don't need the 1 on the bottom, because 7 divided by 1 is 7. All right, last one. So I think you're getting the hang of it, right? You're getting the flow of this. 1/9. Oh, and by the way, now that I just thought about it, I see some students not write the original problem down here. I see some students automatically just do this. And, change the division to multiplication to save some time writing it or save some paper. I don't know. Not a good idea. Because if you ever have to go back to your notes for this class, another class, some class 2 years down the road, or who knows how long, you can't see that this was originally division. It just looks like a multiplication problem. You can't even tell it's division, right? Look, I don't see any division anywhere. So even though it's a little bit more writing, write it down the way it is shown here. Always do that for every problem, okay, in math. Start with the original problem, the way it is asked for you to solve it, and then show your steps below or to the side or whatever. All right, so let's go back and write it the way it is. So keep that in mind. Write it the way it is first. All right, so we have this. It's okay. We can handle it. I know it. Keep, change, flip. We already knew that, right? And now we know, oh, this used to be a division problem. Gotcha. All right. All right, well, does not reduce, does not reduce. Anytime you have a 1 involved, you cannot reduce. This reduces pretty nicely. What's the biggest number that divides into 36 and 9 that you're thinking about? Your thought bubble, right? Don't tell me 3. It's not the biggest. You said 9. Correct. 9 divides into 9 once. 9 divides into 36 4 times. And by the way, if you have not seen my video on multiplication of fractions, you should definitely see it, because here I'm assuming you know this already, so I'm going quickly. That was my previous video. All right, so we have 1 times 4 is 4. 1 times 1 is 1. We don't need the 1 on the bottom because we know that 4 divided by 1 is 4. All right, so that's how you perform division of fractions. If you like my video, if you like my content, click the like button, post your comments, and subscribe to my channel. Thank you for watching.